Well, hello everyone. Today we're going to do a tutorial about data visualization with processing. Now, processing, some of you know because you took image, sound, and code last year, and some of you won't know it. Processing is a programming language, Java-based, but you could say somewhat simplified from Java and oriented towards making graphics. It was originally designed as a way to teach people programming, so it is a relatively accessible language. And you can see here there's a processing.org website. It's free software, cross-platform, so you can download it if you don't already have it for your platform. There's also a very large reference section. There are multiple libraries for different purposes. So I'm really just going to start this tutorial by showing you some things that have been done by students in the past at Bath Spa with processing and data visualization. So Flourish is a great tool, and if you decide to use Flourish, that's fine. I might also mention that Flourish also has a developers section. You can click on this link up here. You'll see there's an SDK. They have an API that you can check out. There's the API. You can build your own templates if you want to dig deeper into Flourish, which is mainly JavaScript, I believe. I think they actually make use of d3.js, which is a very popular data visualization JavaScript library. But this is what we're not going to do. We are going to look at processing today. And I'm going to start by showing you some processing sketches that were done by previous students. So let's look at this first one, which I think is the most unique, maybe the most unique data visualization I've seen from a student yet. Here we're launching processing. Which is a bit slow. I can maybe make the font a bit larger so you can see it a bit better. So you can see there's declaration of various variables here. Processing is an object-oriented language, and this person has actually created a series of classes here called balloon, bus, car, cloud, roads. And here's the main sketch where she's created instances of these classes. You have the standard data types, float, int, image is another data type. It says p image because it's processing image. And then the basic structure is that you have setup function where you load things and initialize your variables. And then you have the draw loop, which runs by default at 60 cycles per second and is looping constantly. You can see here there's a relatively long set of code. And mouse clicked is a separate function, so if you use mouse clicked, that is an event handler that's running constantly. But let's just run this and actually see what it looks like. So you can see first, this is good practice. It has a set of instructions telling you how to use it. It's an interactive data visualization about how the residents of London feel about their city and local neighborhoods. And we can just press any key to start the visualization. And also if we click, we'll see some red dots where there are hotspots. So as you can see, this is a kind of animated, stylized, playful representation of a London neighborhood. And of London itself, we have the Tower Bridge up in the upper right. And if we start to hover, we start to get statistics. 58% of Londoners agree that their local sport and leisure facilities are good. Of course, this is appropriate to be hovering over the park for this kind of statistic. We hover over the clouds and we get statistics about the air. We hover over the street. Can be, if we click, we can see where the hot spots are. Okay, so it's here. 31% of Londoners agree it's safe to cycle in their local area. So here's the cyclist. 42% of Londoners agree that there's a range of arts and community activities, tourist issues. So in short, this is a really unique way of presenting data. You could say it in a way, it tells a story. And I think probably that's as much as I can say about it. It's a really good example of an imaginative use of processing for data visualization. So let's look at some other examples. This is a simpler data visualization, which is showing, I guess it must be annual rainfall in the UK, starting from 1961, going all the way to 2011. I click on the gray bar here and it chooses a year, 1983, 1991. We have a legend at the top, 1,134 millimeters of rain. Each raindrop equals a millimeter. That actually doesn't seem to pan out with the animation because the raindrops just keep falling and falling. So I think we probably need a bit more information with this one, but it is a unique way of, again, of doing data visualization by doing an animation related to the data being presented. Add another. So this visualization, you can see there's the basic instructions here. Use left and right arrows, a date, December of 2000. We see the US dollar, the euro, British pound, Australian dollar. The pound is strong against the dollars and the euro. And if we click the right arrow, we morph forward in time, month by month, and see how they performed against each other. And eventually, if I just keep going, we see the New Zealand dollar comes in. Maybe there wasn't data before that. But eventually here, the Bitcoin is going to show up because this is really a data visualization about Bitcoin. So you can see Bitcoin actually came in, all right. August 2010, rather weak, but becomes very strong against these other currencies very rapidly. Fluctuates quite wildly, but very strong against all the others. We see gold come into the picture and how that rates against Bitcoin and the typical currencies. And this takes us up through December 2017, Bitcoin kind of outperforming gold and these other currencies by a wide margin. So this is, again, a bespoke data visualization that related to the interest of the student, the interest that he had in Bitcoin. And it's interactive as well. This is a map-based visualization from a student of, I think, now 3 years ago. It shows the world homicide rate per 100,000 people by country. Dark green is more dangerous, it says. White is least dangerous. Danger being based on the homicide rate. So places like Canada, however, you see it has a rate of 1.5. The UK, 0.9. Honduras, or here's Panama, 17. Honduras, 84, which I think has been the highest in the world for a while now. So it's in some ways simple, but it's elegant. The dots are clear. They're not colliding with each other. They're maybe a touch small, but I think that was, he felt necessary to fit them all on. But overall, this was a nicely done data visualization by a previous student. Now this one says British abroad. It doesn't give quite as much information as it should, I think, as data plotted as a percentage of total assistance required in those countries. So I guess this is British people who traveled abroad and lost their passports. So this is a scatter plot. You see the x-axis here is hospitalized. I guess numbers hospitalized. We don't actually get any numbers. That could be another critique. We could level at this. Sketch y-axis is total arrests. Size is the number of passports lost or stolen, I gather. And the color is the continent that it comes from. We hover, we get the country. So red is Europe. These are all European countries in red. Another critique, white text on yellow doesn't read well. Can't really see. This is India, Saudi Arabia, Malaysia. So this is Asia and Southeast Asia. Well, let's actually toggle this so that we get more readable text. Now, sort of what's a virtue of this particular sketch is that you can change what's plotted by typing the numbers 1 through 7, and it changes what's on the x-axis. So now it's drug arrests. Now I'm plotting total arrest against total arrest, so of course it's just linear. That doesn't really make sense. Now total deaths against total arrest. Hospitalized against total arrest. If I press the letters Q through U, I can change what's on the y-axis. Here's hospitalized against sexual assault. So I think in some ways this is quite clever because it gives us the option for multiple combinations in terms of what we're plotting against the y and x axis. Maybe we could ask the question, though, what does it really tell us if we plot hospitalized against total deaths? Is that really telling a story? Is it giving us an insight? It's not clear to me that it is. So sort of technically, this is quite well done. Again, the size is the number of passports lost or stolen, and the color showing the continent. So one thing to note about scatter plots in general is that they do allow you to show, in this case, 4 different parameters on one 2-dimensional graph. So as we have the x-axis, the y-axis, we have the size and the color of the dot. And actually, I guess that's 5 parameters because when we roll over, we get the 5th, which is the country name. Let's toggle back. Dark blue. Peru. Okay, you get the idea for what's going on. Let's look at one more. example, which is someone who has made his own version of a cluster dendrogram. Now this is getting cut off because the screen has not been properly sized. In the setup here, the screen size is 2000 by 1500. And the my viewport simply is not that large, so it's better when you make a sketch to, instead of using a hard-coded size, to get the viewport width and adjust accordingly. But let's look at a screen capture of this to see what it actually looks like if rendered on a screen that can manage it. So here we have it. Just one of those types you'll see and Flourish, a dendrogram. And it's a fairly good solution. So Murders in London by Borough from 2006 to 2011. We see there's a total of 838, and we can see for each borough in London how many there were. It's very clear that Hackney had a large number, Lambeth a very large number, Richmond very small, and we can sort of speculate about why that is, especially if you know some of those neighborhoods. In terms of technique, it's nice that he used the Bezier curves to make this diagram. Those who took image, sound, and code will know. Remember, I'm a great fan of Bezier curves and what you can do with them. Okay, so that ends my little survey of student examples. There's quite a good variety there. And I just want to show you now an example of my own, which is going to be a scatter plot. Let's just get rid of these others. So first of all, let's just look at the data. In a processing folder, you always have a data folder, at least if you're using any data. This is a fake data file that I created. I'm going to post this on Aula, the sketch. This is a CSV file, comma separated values. And a quite simple one. The fake data is that we have name, age, zip code, number of purchases, and total spent. So here I have Karen Kitty. She's 32, lives in zip code 49502, made 3 purchases and spent a total of $5.55, etc. There's only 100 data points in this file, so it's really here just to illustrate the mechanics of processing and not as a really useful data file. You can see that in processing, these files are loaded by using the table data type and then using the load table command to actually load the data. And I'll just show you what this looks like currently. So if we roll over, we get the number of purchases. X-axis is age. Y-axis is total spent. The size of the circle is the number of purchases. Color is the zip code. So if we're mapping age against total spent, kind of what this graph tells us is that when people are sort of between 40 and say 65 or 70, they have a fair amount of disposable income. They're spending more. Doesn't say what kinds of items these are. That would be part of the story, of course. The color scheme here is not good. Admittedly, this was a bit of a kludge. I should improve the color scheme. But it does show you that it's not too difficult to make a sketch that does something as simple as a scatter plot. I've had to use the 3D portion of processing so that I can rotate that text over on the left-hand column. I've got these sections labeled, sections for my legend, the axis labels, displaying the age and dollars labels, displaying the dots, using a for loop to go through the data file and get the data I want and to visualize it. I have scaled it in a kind of not the most elegant way. You can see I've sort of amplified the size to make it fit onto the canvas. Ideally, again, this should be done relative to the size and not hard-coded. But there it is, and I've built a very simple assign color function because I knew there were only 8 zip codes, and I just very quickly assigned a series of colors to those. And then that gets called when here it is, assign color gets called when the dot is displayed. So I'll post this to Aula. You can look at it and we can use it in the workshop. And you can also make changes. You can imagine how this template could be changed to show a bar graph, for example, instead of a scatter plot. You can use the rect command for a rectangle to draw bars instead of circles. So that's it for now. As I said before, I encourage you to go to the processing website if you're interested. Download lots of tutorials. Here you'll see there's lots of tutorials for processing if you want to learn it. The first example I showed you was done by a young woman who didn't know processing and learned it in order to do her assessment. So it is doable. Okay, that's it for today. I will see you tomorrow in the workshop and we can go further.